Yo, what is up? Episode 41. Yeah, it's Friday, so let's go. But yeah, let's get straight into it. Let's do our Pokemon sound of the day. 041. Actually, 041. Oh, so 040. No, we want 041. Zubat. The classic Zubat. Zubat noise. Let's listen to it one more time. I feel like every single noise mine is the same other than ones that actually kind of say something. The cave area national anthem. Caves in a nutshell. Steps in the cave, Zubat. Yep, Zubat's a classic one that you get. I'm going through a cave. Nice. Okay. Yeah, let's get straight into it. We're gonna finish. I think we finished the linked list problems yesterday. Let's check out here. We did. We have solved every single one. Let's check out our stack problems. I think we've nearly solved every single one. Yeah, with 2 left. What do we got? We got minimum surges to balance, parenthesis. Asteroid collision. Let's take a look at this one, and then we'll move on. We might do another stack tomorrow, and maybe we'll do a binary search tree or something after this. I'm sure I've probably nearly gone through all these to 16 out of 46. Take a look at maybe these ones again. I don't know. Yeah, so stacking queue. Yeah, let's take a look at this one. So. Okay, write these string guys containing other characters. That's a nice message. Okay. We got 1 here. So we need to add 1. Okay. This doesn't require any because we have 2 here. This requires 3 because we have to add 1 of these for this one. Then this one's got this, and then we need 2 right ones. Yeah. Okay. Interesting problem. So the way I want to think about this problem is, let's open up our paint. All right, so we got our stack here. We got our, let's just use this input. We got this one, this one, this one, this one, this one. So I guess we got to think about our input here. So obviously the first thing we want to see is we want to see one of these, right? That's our first thing that we want to see. All right, so if we see this, then we can just, I guess, append to the stack, right? So we append this to the stack, I think. And we loop through. If we see this, maybe we might have to keep track of what we have seen. I'm trying to think. Because this is technically what we want to see, right? We do want to see this. So I guess we've technically maybe got to keep a count of some sort of how many opens we have and how many closes we have. I don't think technically we need a stack to do this. I think we can do this just using a string. So let's try with that. Let's try and just kind of get the string solution going. So I guess we can do for char and s. We can keep our open bracket is equal to 0. Close bracket is equal to 0. Right? Do for char and s. If char is equal to a open bracket here, then we can just increase open bracket by 1, right? Else, I guess we need else if char is equal to this one, closing bracket. What do we want to do if we see a closing bracket? We want to you want to check to see, well, if open bracket is equal to 1 and close bracket, I guess we can just add, right? I guess we can do close bracket plus equal to 1. We can check, well, if open bracket is equal to 1, and I guess we want to look, actually we want to look for the open case. So we want it, if it's above 1, we have an open bracket that's above 1, and close bracket is greater than or equal to 2. This needs to be equal. If it's greater than or equal to 2, then we just want to decrease open bracket minus equal to 1, close bracket minus equal to 2. Now I guess whatever is valid that's left, I guess we would just return our sum of closed, not the sum we want. Just return open bracket plus close bracket. I don't know if this will work, but yeah, so this case, this didn't work. So for a case that we're looking at here, it didn't work. Why is that? We're expecting 1, but we have 2. Well, let's go through this algorithm. So we see this, we append. See this, we add 1. Right, so our open bracket is 1. I'm going to represent this with O. And see open bracket for this one, close bracket for this one, right? So we see 1, we add 1. See this one, we add 2. So now we're at 2. We see this, it's 1. If open bracket is greater than or equal to 1, and close bracket, we skip this step. So we just increase close bracket. And we go for the next chart here. So here, this is 2 now. So this is 2. So now they're both greater than or equal to 2. So then we decrease open bracket by 1. So now open bracket is 1 and close bracket is 0. So now we want to do, so now we add this one, which is 1. Okay, so technically we want to return the remainder. There's something wrong in our algorithm here. Technically we're returning 2 here, but we need to return trying to think here. Oh, we need to return. I guess we need to kind of return something else. So I guess we need to look at how many close brackets we have left and how many opens we have, because technically if we had one closing bracket, we need an open and a closing to make it valid. So in this case, technically we always need, we need to do something individually with both of them, but I'm not sure the kind of math that we need off the top of my head. Maybe we do... Because technically if we have two closing brackets, we could have 5 closing brackets. We'd only need 1 opening bracket, right? So it's like... But then if we have 1 closing bracket, we need an opening and a closing. So either we could return 3. We would need the, what is the math though for the, I'm trying to think, what would be the math? We need some sort of math here to return, but I'm not sure off the top of my head. I'm gonna ask the internet because I'm not sure. Okay, so what they do here is they do open brackets. Okay, well, so that's if we just open bracket plus 1. Else, if I plus 1 is less than like this, and I. Return open bracket. Can we technically return 4? What's the thing? So here we can do, well, if we could do all the different cases here, but I don't know if that's even worth it. Like, if open bracket is greater than or equal to because we could have like 10 fucking closing brackets, like then we gotta do it for each case, so that wouldn't work. Gotta think of a different way to do this within the code, like char as if char is equal to this open bracket plus equal 1 else char is equal to this. I think we need to redo this logic. What else? We gotta think, well, if we see a, just make sure we get this in my head. If we see a closing, actually I'm just gonna do closing. Okay, if I plus 1 is less than the length of S, and S I plus 1 is equal to a closing bracket, and we can just, I guess we can just increment I, right? Else, I need this, I guess we can do our number of insertions. This is what we're going to return, the number of insertions. We can do else insertions plus or equal to 1. Because if we don't see one of these, then we're going to need an insertion anyway, right? Technically. So here we're individually checking the cases. So here it's saying that we're individually checking these, right? So individually checking separate ifs, right? Individually checking separate ifs, right? Because we don't see this, we do an insertion, but if our open bracket greater than or equal to 1, then we can use one of our open brackets, right? So open bracket minus or equal 1, else so we check this if statement first, right? Which is this one here. Any left parenthesis must have corresponding 2 consecutive right parentheses. I guess maybe we could do it a different way, maybe, where we could do an else if here. So I guess we have this, sorry, if this, right? We could check. Here we have just insertions plus equal 1. I don't like this way though. This isn't what I like. I don't like this. Like, this is. I think this can be done way simpler. Like, if this is this, we increase this. Else, if we see this, we want to check. Well, if I guess we need to think about the opposite of this, right? Like, and open bracket is greater than or equal to 1, then we can skip, right? Also, if it's not, then we have an insertion plus 1, right? Don't need to increase here. right? Else if it's not this, then see, I kind of like it with the closing bracket, you know. Spending way too much time on this problem, bro. Oh my gosh. If open brackets 1, individually check separate ifs. We continue, right? Closing bracket plus or equal to 1. That's equal to 1, right? We're back to where we were at. Closing bracket is equal to 0. Then we can well, that would never happen. We'd never have 0 and 0. Go to 1 and open bracket is equal to 0, then we can turn to else if closing bracket is equal to 2 and open bracket is equal to 0, we return 1, else if closing bracket and open bracket equal to 1, then we guess we could combine this in the same if statement, closing bracket and open bracket equal to 1, we would return this. bracket equal to 0 and no, this wouldn't work, bro. No, because like we could keep going forever higher, higher and higher and higher, and like I'm gonna have to do every single case. This would not work. Like, bro. Jesus, dude. Y is less than like this. If si is equal to this, then open bracket plus equal 1. Alright, else is equal to this. Then we do we check if I is less I plus 1 is less than the length of S, and Si plus 1 equal to this, sorry, this, then we do a I plus equal to 1. Else it's plus equal to 1 because we need an extra, this one, right? Open bracket is greater than or equal to 1. Equal 1, then we want to just increment by I every single time, right? I plus equal 1. We want to return plus open bracket times 2. Bro, I feel like this is just all math, bro. Like, there's like, oh. I do a C here, bro? Bro, what am I doing? Okay, so this checks the front value else. go through this by itself. I'm honestly not sure. Okay, so we got boom, oh, boom, 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 boom. All right, we got an open bracket. I'm just gonna do that with O, and we got our insertions I, right? Go to this one, we see this. This is this, then open bracket is 1. Okay, we see this, open bracket is 2, right? 2 here. We see this, see else here. If I plus 1 is less than length, yes, and si plus 1 is equal to this, it is, and we just increment I, right? So we increment I. So we increment I to I plus 1. Okay, so I guess, hang on, wait. Let's do insertions, right? And then we have I. Let's do it again. So we do this, we got O, we got 2, and then we go here. This is currently 0. This is currently 1, 0, 1, 2. So we're currently at I is equal to 2, right? But here we see this is correct, and we do I is equal to 3, right? So we're at this value here. So I is now equal to 3. And we check, well, if open bracket is greater than or equal to 1, and it is, we decrease by 1, right? So this is now 1. Then we go I plus 1, so now we're at 4. Okay, so now we're at 4, we check this. Well, come over here, we see that it's this one. It doesn't go to here because then we go out of bounds. And we check, well, if open bracket is greater than or equal to 1, which it is, then we decrement by 1. So we're at 0 here now. Else this, I plus 1. So technically our I is at 4, we have 0, 0. Did I do that correctly? Like, we return insertions plus open bracket times 2. So technically we return fucking 0. But that's wrong, so I definitely... Did I give the wrong event? No. Open bracket is equal to 2, okay. Oh, then we insert here. Ah, okay, right. So I just had to get a 1 here, that's why I didn't do anything. I don't really like this solution, to be honest. I just don't get how you would think of something like that. Like, bro, I've spent 40 minutes trying to do this, bro. Like, jeez, dude, what the fuck is this? Overview. This is exactly what we did here. Here we had let's go through this one really quick. See what we return. Right, so then we're gonna do the stack version. Maybe the stack version might be easier to understand, potentially. Okay, so we got right, so okay, start here, we see this, right? We need an extra thing, so our insertion goes up by 1, right? If open bracket is greater than or equal to 1, it's not. Our insertion goes up by 1, so our insertion goes to 2. And then we increase this one here, right? So now we're here. See this. Oh wait, no, sorry. What am I doing? We go here. We see, okay, we're here. If we see, if our length is less than this and this is this, we see that. Then we do plus I plus or equal to 1, right? We skip, right? So now our I is equal to 0, our I is 1, but we're actually going to go to this value here in our next loop, right? So we're going to go here. We haven't changed anything. This is still 0. Then we check here. Well, if open bracket is greater than or equal to 1, which it's not, then we make an insertion, right? So we go 1 here. Now we loop to this. Now we're here. We see an open bracket. Now our open bracket is 1, right? Then we see another close. We see 2 closes in a row. Well, we see 2 closes. If I plus or equal to 1 and length is this, then we skip I, so we go to here. Well, now open bracket is greater than or equal to 1, so then we do a open bracket minus or equal to 1. So this goes to 0. Then we increase by I. Then we have we're here. We see an open bracket, so then our open goes up by 1. So 1. Insertions of 1, 1, then we do insertions plus open bracket, it's 4, so then we return 4. How the return 3 here, bro? Like, what? What? Let's submit this. That's interesting. Bro, I don't understand. We got the exact same here, but 2. Oh, 1 plus 1 times 2. Jeez, I'm so stupid. Oh my god. So that's why it's 3. I just messed up this calculation at the end. Okay. So now I guess we want to think about it kind of like a stack. Alright, so how would we think about it as a stack? How do we think about using a stack with this? So I guess we compare it with the closing parentheses that if our, oh my gosh. So I guess char and s. I don't know if char is equal to this, right? Let's do 0 close brackets is equal to 0, right? See an open bracket, we just increase open plus equal 1. Else, all right, we see a closing bracket, right? Then we want to, I guess we append to our stack dot append stack dot append char. Then we want to check, well, if stack and stack negative on top of our stack we don't want to append yet. We want to check first. We want to check if our stack and the top of our stack is equal to char. Then we can increase by 1, right? So while loop while to initialize here while I is less than the length of s, then we increase by 1, right? It'd be nice to have a book right here, right now, honestly, to think about this. Like, better see if I have a book. Okay, so I'm gonna have to use this. So, fuck, I'm just gonna make a new one. Oh my god. So now we have a stack, right? What I was thinking was that, I mean, if we keep adding these values, right? So let's say we're going to process our first one here. Boom, 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 boom. We also got to think about the order too. That's also... yeah, it's not going to work because we got to think about the order. closing parenthesis, then we do, so each time we see this, we increase by that. We see a closing parenthesis, I guess maybe we could use the stack as elements holding this, and then if we see actually there's like if asked alright, then we've got two values in it already, right? And we do I plus or equal to 1. We pop from our stack. Else we just want to append stack.append char, right? I think that's probably the way to go about it. If stack minus 1 is equal to char, so we're checking if we got two values here. So we're looking at this value. That is stack minus 1 here, right? And then this is char, right? This is char, okay? Then we know we found a valid stack. Else, if it's not, if this top of our stack then we just want to append. Well, this is always going to be empty because we're only holding these values. Every time we're popping here, I don't know if this is going to work, dude. This is such a confusing problem, bro. Like, I don't think this will work though, because how are we thinking about the insertions here? Like, we have to think about it with the insertion. So let's equal 1, and if our open bracket is greater than or equal to 1, open brackets minus or equal to 1, else insertions plus or equal to 1, then we would just return, no, we still want to increase our while loop, I plus or equal to 1, we return versions plus open brackets times 2. This is such a confusing stack problem, bro. Like, oh my gosh. God, I'm starting to get angry at Leetcode, bro. Oh my god, dude. Dude, this problem is so tough to think about, bro. Like, the math behind the problem is just, like, ridiculous, bro. Like, Now we got char, bro, equal to si, dude, bro. Yeah, you know, I'm not sure. Sometimes, bro, I just feel like I'm not smart enough for these problems, man. Like, got a pen this else. I plus 1 is less than the length of s. And it's I plus 1 is equal to this. I plus equal to 1, right? Else you want to do an insertion. Right. Okay, let's think about this problem in terms of stack. Okay. So we see this, see an opening bracket, we append, right? We see this, we append. Okay, simple as that. See a closing bracket. Well, if I plus 1 is the length, we check the second most there. If it is, we do I plus 1, right? So now instead of being at 3, we're going to check this value next, right? So, yeah. And if stack, we stacked our pop, right? So we pop from the stack. And then we do I plus 1. So then we check this value, right? So is this value... is this? Well, no, then our insertions goes up by 1, so our insertions is equal to 1. If stacked, then we stacked our pop. Yeah. Okay, and then we got plus 1, so we end the while loops, then we have insertions, plus the length of the stack is 0 times 2, so we return 1. And that's our answer. That one's a lot easier to think about, but I just don't get how you think like this. I just don't get like how you like can do that off the top of the head. Like, you know that, you know, like I was thinking in a different way and was trying to think of the math. Maybe there is a way that you can do it like that, but I'm not 100% sure. But it's like, yeah. Well, stack is pretty much holding these here, right? Whenever appending, it's just we're holding our front ones. It's so interesting to think like that. Like how it's tough, bro. Like, all right, we're gonna call that, man. Like we spent what, an hour on that problem, dude. Insane. It's 100%. Does not beat 100%. Same method. I guess that's a good way to think about it. Scan the string if the right percentage comes to check. Comes and check if that's the case. He comes and check if that's. Wait. Scan the string, and if the right parenthesis comes, then check there is another. If that's the case, then check if bow is greater than 0. It means it is already balanced. If not, then it means we need a left one to balance it. So then you increase the insertion. Interesting. Yeah, interesting problem for sure. We're gonna do something different. Maybe let's do a binary tree one. I don't know. Again, I haven't looked at these ones in like forever, so it's like, bruh. Jeez, man, that's a lot of these problems. Let's kind of look at this problem. When did we do this? Yeah, it had to be December. It's been a while ago. Given the root of a tree, return all root level paths in any order. Alright, so I think you can implement this 2 different ways. I think you can do it, yeah, a depth first search, or you can backtrack. What is this? Binary tree, depth first search, tree, backtracking, string. I think breadth first search uses a queue, right? BFS uses queue. I think, yeah, it uses queue data structure, and then DFS uses a stack, right? DFS utilizes a stack data structure. Okay. Well, maybe we could do, well, you could do, what is root dot? S is equal to root dot left. Let's print S. Two. What are we doing here? We're printing, given the root of a binary tree, return all root to leaf paths in any order. Return all root to leaf paths in any order. Root to leaf paths. So if we have a res if backtrack, we need our base case. Well, I guess if I guess if root dot left, let's call this x is equal to root. I guess if x dot left and x dot right is equal to none, x dot right is equal to none and x dot equal to none, then we just res dot append cur dot copy. Alright, then we do our recursive case, and we do, well, it's hard to think of the recursive case here. Or was it like if root dot right stupid extra. X dot right, X dot left. You need like a stacked up plot. I actually don't know what the recursive case here would be. What would the recursive case be here? Base case leaf node, add path to result. If not, backtrack base case. Passing on node. Alright, so our base case is, well, if not, node dot left, and if and not node dot right, so that means check left and right if leaf node, right? So you need it both empty for it to be a leaf node. Then apparently we need to append this dot join cur. Then we need, this is our recursive case. If node dot left, backtrack, node dot left. If node dot right, backtrack, node.write. We do cur.pop. Then we backtrack, root, turn res. Where the fuck is X? Where the hell is oh shit, we're not appending. Whoops. Add node. Cur.append string node.val. Okay. I guess that's the backtracking way, right? There's many other ways that you can do this though. You can do this backtracking, DFS, or I guess we can do ways you can solve this problem. I kind of want to do all the different ways that you can solve this, so like then you can practice all the different things. And obviously this method is slow because we're constantly how is this DFS? Okay. I'm curious, what did I do here? I actually did DFS. So I guess tree problems, we want to do a recursive approach, sorry, a backtracking approach, and then I want to do the iterative DFS or BFS. Alright. Okay. Okay, how do we do a DFS approach here? The root of binary tree pretend all root to leave paths in any order, right? So get rid of this. We obviously need stack. Right. Sure, the root is empty. Okay. That stack, what do we want to hold? Probably two separate values, right? Like, trying to think about this, man. First and first that bit. Stack is equal to root string root. What are we doing here? We're checking obviously if our root is empty. We have our res array. We have our stack. We want to pass in our actual node that we're looking at. A string value of the value of the root. While our stack. Node path is equals. Push the right child first. I can't remember. So, right Jeez, man. Like, I understand, bro, but I find it hard to put it to code, like, what I'm thinking. Like, I don't know if that's... Okay, we're just gonna do this, right? So we want a node here, and we want the string of the node of the value, right? To go here. Guess we're gonna start getting into some BFS problems. While stack, what do we want to do? Do we want to is equal to stacked up plot. Oh, no dot left, and this is the base case, right? So if it's a leaf, not node dot left and not node dot right, then we want to do res dot append. What are we appending? Where have we initialized that path? Oh, yeah. Okay, then if node dot right, we want to stack dot append node dot right, then path plus this plus, I guess, like node dot right or something. String node dot right dot val. Node dot left, stack dot append node dot right, path plus string node dot left dot val. Node dot left. And obviously we want to just turn our res. Alright, yeah. Kind of actually look variable node. Aren't we doing, why would we node isn't a root? Root. Jeez. Okay. We're gonna call it for this problem. I mean, bro, we've been going for like, what, nearly an hour and 40 minutes, man. Jeez. Let's jump on and do something different. We'll do like a hash map problem. Maybe something easy to finish out. Let's do joules and stones. I don't even know what this is, but let's take a look. Okay. Given strings joules representing the types of stones that are joules. Given a strings joules representing the types of stones that are joules, and stones representing the stones you have. Each character stones is the type of stone you have. You want to know how many stones you have. Or also joules. Oh my god, that was so confusing. The case sensitive, so A is considered a different type of stone from A. So why is it outputting 3? You're given string joules representing the types of stones that are joules. Oh, okay. It's because we see an A, an A, and an A, right? Because this is what we have here. A. Let's just look at the topics of this. Hash table string. Okay, so I was going to say we're going to use a dictionary. I was going to say we could create a dictionary. -dict. I'm guessing I'm going to assume that these are always going to be unique, I would think, the joules. Is that how you form a dictionary? Dude, I'm like blanking out right now. Valid syntax. I'm thinking of Java, dude. I don't know. Bro. I'll do a dictionary. Bro, is this still going? Oh my gosh, I'm thinking of Java. Okay. I think that's good, right? Okay. Alright, so we loop through I in range length joules, right? I guess we can just do for I in joules. If my_dict joules in my dictionary, then we can do my_dict. I guess we're always gonna know that they're gonna be different. So, but does dictionaries, my_dict joules, my_dict joules, not in my dictionary. We can just do equal 1, right? Let's just print our dictionary because I'm curious to see what. Is there something wrong with this syntax here? my_dict joules, not in my dictionary. That's what I got, right? Okay, wait. Range length joules. Range length joules. If joules I in my dictionary. Joules I. Oh my gosh. If joules I plus equal 1, right? Else, if it isn't, I just go to joules I equal to, sorry, equal 1. Okay, let's print my dictionary. Man. Okay, good. We're getting two separate, right? Technically, I don't think this is really necessary. Actually, we'll leave it for now. I don't think this is necessary because technically it's always going to be different. It's going to be unique, so I mean, I don't know. That's fine. Okay, so then we just do, I guess, another loop for I in range length stones if range length stones if stones I is equal to stones I in my dictionary. We're doing the same thing. My dictionary stones I guess we need a count variable to return, so in my dictionary, then we can just do count plus equal 1, else, I mean, we just don't do anything, right? We don't even need an else. I guess we can just return our return our count. I think this should work. Okay, right. I don't think we even need this. I don't think this is needed. I think we can just do this. Because always gonna be unique. Yeah. Nice. What's a better way that you can do this instead of two separate for loops? Maybe you can. Is there like doc contains in Python? There isn't. If word in text. Maybe we can do, well, I mean, another way we can do it is, well, I'm just playing around with Python here. Can we do like a slice joules is equal to list joules? Can we print slice joules? What can we do like? I guess, can't we do like for I if I in slice joules count plus equal 1. Can you try that maybe? Count plus equal 1. Yes. Can we turn that count? I wonder if this will work. I'm not really too sure. Can't actually look at variable count when it's associated with a value. Oh my gosh. Oops. Oh, that works too. Okay. It's a bit slower. I guess what other solutions is there? Like, joule set is equal to set joules. I guess you could use set as well. Didn't think about that. Definitely could. That is a smart way to do it. Just gotta use the hash map.